Hello and welcome to Video Podcast 10.4. In this podcast, we will learn about ocean tides. For starters, if you think you're going to get a roll tide out of me at any point during this video, or at any point during class, please consider this my official response.
I'm not going to, so quit asking. I'm not going to, so quit asking. I'm not going to, so quit asking.
Now that we got that out of the way, let's get on to the science of ocean tides. Ocean tides are defined as daily changes in elevation of the ocean surface. The tides are caused by gravitational forces exerted upon Earth by the Moon, and to a lesser extent by the Sun. Although the Sun is many millions of times bigger than our Moon, its gravitational tug is only about half of that of the Moon's gravitational tug. That's because the force of gravity diminishes exponentially with distance. The Sun, although much bigger than the Moon, is also much further away from planet Earth. The GIF on the screen provides a really good visual depiction for how the Moon is responsible for ocean tides. As the Moon revolves around planet Earth, you can see that it pulls a tidal bulge along with it. That tidal bulge is caused by the gravitational attraction between the Earth and the Moon. You can think of the gravitational tug by the Moon as elongating Earth. And although it's quite dramatic, you can almost think of Earth as being pulled into the shape of Stewie Griffin's head by the Moon. As this GIF also shows, there is a tidal bulge on the side nearest to the Moon, as well as on the side furthest from the Moon. Put simply, the two tidal bulges shown are a result of Earth being stretched by the gravitational pull of the Moon. At this point, I'd like to turn it over to Dr. Neil deGrasse Tyson for a really cool insight regarding ocean tides.
Tides are widely misunderstood.
Okay.
All right. I will say the next thing I say may be mind-blowing to you.
Okay.
Okay. The tide doesn't actually come in and out. What? What happens is there is a bulge of water, two of them on opposite sides of the Earth, caused by the Sun and the Moon, and Earth turns inside that bulge. Mm-hmm. So when we say the water rises and falls tidally, what's happening is we are rotating into the bulge and then out of the bulge.
So the bulge is already there.
It's already there.
And all we kind of do is pass through the bulge.
Pass through, and the water gets high and it gets low. So we're stuck with language from our own perspective rather than language of what's actually happening. It's simpler that way to say the water goes in and out. It's simpler to say the sun set rather than Earth rotated such that our angle of view on the stationary sun fell below our local horizon.
Right. Yeah, sunset is far more poetic.
Yeah, you go to the sunset tables, to look this up.
Yeah, because you can't say to a girl, hey, how'd you like to go and watch the angular momentum of the Earth cause the sun to disappear behind a horizon?
Hello, where'd you go?
One thing you may have noticed is that the tidal bulge gets more elongated when the Earth, Moon, and Sun are all in alignment. And now would be a great time to transition to two types of tides that we see on planet Earth. On this slide, I'll overview spring tide and neap tide. Spring tide occurs during new and full moons. And this is when the Earth, Sun, and Moon are all aligned. You can almost think of the Sun as giving the Moon a gravitational assist. During spring tide, you'll see larger tidal troughs and tidal bulges. And that's why in the GIF shown, the tidal bulge gets really elongated when the Sun, Earth, and Moon are all in alignment. During spring tide, you will see a very large tidal range. In other words, high tide is really high and low tide can be really low. The second type of tide we'll talk about is what's known as a neap tide. And neap tides occur during the first and third quarters of the moon. As shown in the image and the GIF on this screen, at neap tide there is a right angle made between the Sun, Earth, and Moon. When neap tide occurs, you'll notice that the gravitational bulge becomes nearly circular. In other words, the elongation of Earth becomes minimized. This is because the gravitational forces of the Sun and the Moon essentially offset and cancel each other out. During neap tide, the daily tidal range is least. In other words, there's not much difference between high tide and low tide. Okay, that concludes this video podcast, and this was the last vodcast of Chapter 10. In our next series of vodcasts, we'll transition to the atmosphere, weather, and climate. And as promised, there will be no roll tide, but we will conclude with a good old-fashioned Rickroll.